Number 16 on our review questions. Graph the function f of x equals the square root of x plus 3 minus 1 on the grid below. Show the table that you created by hand or using your calculator and state the domain and the range. All right, so let's look at the vertex of this one. Inside, we have our x, and remember it's going to be opposite, so that'll be negative 3. Outside, we have our y, which is negative 1. So we have negative 3 and 1. 1, 2, 3, negative 1. We know that it's going to be positive going this way, because remember your a is positive out in front. Let's come up with a table of values to try here. Remember, we've got a square root, so we want to think about putting numbers in here that will make it easier for us using your square roots. So what could I add to x to give me a perfect square? For example, I could add 1, have x is 1, 1 plus 3 is 4, the square root of 4 is 2, 2 take away 1 is 1, so that would give me 1 and 1. If I plug in 0, that will give me 3. If I plug in negative 1, that would give me 2, and that would be difficult to do. If I used 3 here, or negative 3, it would go back to give me negative 1. Negative 2, if I plugged in negative 2, that would give me a perfect square. So these numbers aren't in order. If I plug in negative 2 plus 3 gives me a positive 1. The square root of positive 1 is 1. 1 take away 1 would be 0. So that would be negative 2 and 0. We can use our calculator. Plug in this function. Go to y equals the square root of x plus 3. And then we want to get outside of the radical and use minus 1. Graph it. That's what it's going to look like. Go to your table and see some values. Notice that when you use negative 4, we have an error because that would give us a negative underneath the radical. If we use 1, we'll have 1. That's what we use that. Let's see if we see some other. There's a good one. If we plug in 6, my output would be 2. And if I use 13, my output would be 3. So that's a good set of values to use there. So 6 and 2, 1, 2, 3, 4, 5, 6. And that's about all the values that'll fit on my graph. But that gives us a good idea of what this square root function looks like. The domain. So my domain starts here. My domain is all x values greater than or equal to negative 3. For my interval notation, I would have a bracket for negative 3, comma, parentheses, infinity parentheses. My range is based on my y's, so that'll be y is greater than or equal to negative 1. My interval notation will be bracket, negative 1, comma, infinity parentheses. 17. Give an example of a non-integer rational number and an irrational number. Okay, so a non-integer rational number. Okay, so rational means it's got to be a fraction. Non-integer is basically telling me to come up with a fraction. So I'm going to go with 3/4 there. An irrational number. Think about your square roots that we've been talking about. Square root of 2, square root of 5. These are not perfect squares, so that'll give you an irrational number, a number that can not be written as a fraction. If you added 2 numbers, would the sum be rational or irrational? If you added your 2 numbers, okay, so we're adding a rational number and an irrational. So if we added these 2 up, what would we get? Well, the sum would be irrational. The sum would be irrational. Because anytime that you're adding a rational number to an irrational to a rational, it would be irrational. 18. The graph f of x equals the absolute value of x is shown below along with the graph of g of x. Determine the formula for the function. All right, so f of x is our standard absolute value, but we notice that the g of x is shifting down 1, 2, 3, down 3 units. So g of x would be down 3 units. That goes outside of your absolute value bars. And I'm shifting over to the right 2 units. So that's the part that's going to go inside your absolute value bar. I'm going right, which is positive, but remember you got to think opposite. So it'll be -2 or -2 inside your absolute value bars for g of x. So up and down deals with your y, which is outside. Left or right is inside your absolute value bars and opposite. 19. Solve the following equation for the values of x. Well, let's see what we've got here. So we want to basically undo all of our order of operations. We can subtract 13 from both sides. That gives me 2 times x minus 5 squared, 31, take away 13, gives me 18. Then we want to get rid of this 2. This is 2 times, so we want to do the inverse operation by dividing. Cancels that out. That gives me x minus 5 squared. 18 divided by 2 gives me 9. Here's where we want to take the square root of both sides. Remember, the square root and that exponent of 2 cancel each other out to give you x minus 5. When you take the square root of both sides, remember you are taking the positive and negative form of that square root, and that is a perfect square. 3, add 5 to both sides, and it's going to go out in front. So you've got 5 plus 3 is one value of x, and then you have 5 minus 3. 5 plus 3 gives you an 8. 5 minus 3 gives you 2. So you've got 2 solutions, 8 and 2. 20. Solve the following equation for the value of x. Express your answer in simplest radical form. All right, so we still have to undo all these operations. So first we're going to subtract 7 from both sides. X plus 2 squared divided by 5. 16 take away 7 gives me 9. Then this is division, so I want to multiply both sides by 5. That gets rid of that. X plus 2 squared, 9 times 5 gives me 45. Take the square root of both sides, that cancels that out. X plus 2 equals the plus or minus square root of 45. 45 is not a perfect square. We also need to think about, is there a perfect square inside 45? So I'm going to come out to the side here and look at the square root of 45 and take out the perfect square. Remember, you want to take out the biggest perfect square. And I'm thinking 9 times 5. 9 is my perfect square. The square root of 9 is 3, so that gives me 3 square root of 5. Take that back over here, subtract 2. So I've got a -2 plus or minus 3 square root of 5. You could leave it like that. You could break it apart, but that does give you your 2 solutions in the simplest radical form. 21. Solve the following quadratic equation for all the values of x using the method of completing the square. I'm not going to use completing the square. You can. That's an option. I just want to solve it. So 5 factors of 5 that add to give me 8. Can't be factored. I can use quadratic formula. It says using the completing the square, so I'm going to use my axis of symmetry formula. -b over 2a. So that gives me 8 over 2, which is 4. Plug that back in. 4 squared minus 8 times 4 plus 5. And 4 squared gives me 16 minus 32 plus 5. 16, take away 32 plus 5 gives me negative 11. So there's my x, there's my y for my vertex. So my vertex formula would be y equals, a of course is still 1, x minus 4 squared minus 11. I'm going to take that y out and solve for x. So I'm going to add 11. That gives me x minus 4 squared. Take the square root of both sides. I've got plus or minus the square root of 11 equals x minus 4. Add 4 to both sides. So that's going to give me 4 plus or minus the square root of 11. And that is in simplest radical form. There's not a perfect square inside of 11 that we need to take out. 22, algebraically determine the solutions to the equation below, rounding the answer to the nearest hundredth. All right, so we're rounding on this one. It doesn't tell me which method to solve for. Let's try using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, there's some lovely songs out there that can help you memorize this. Remember that underneath the radical is your discriminant, and that tells us how many solutions we will have. So we always want to calculate that first. So let's see, let's start over here. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. First, the discriminant, negative 10 plus or minus, what's underneath that radical? 10 squared is 100. 100, take away 4 times 3 times negative 5. And that gives me 160. That's positive, so since it's positive, that's going to give me 2 solutions. So we have to keep going to figure out what those 2 solutions are. 2 times 3 gives me 6. Now, since it says round to the nearest hundredth, I don't need to worry